wait for it for falling out.
Yeah.
Who's doing
Cool.
Dude, AJ, check out my slide.
Alright, is it ready though?
No idea. Look ready? Yeah.
I'll get there.
And had me already like run around like 4 to 4. Nothing really.
I would
Like a month before that.
Can anyone check our live stream? Just double check our live stream.
That's what I'm doing right now.
Oh, sorry. So what did you just insert in your slide?
They put it back, they got it set.
Alright.
The tell logo.
Okay.
So you can
Yeah.
start things off whenever you want, man.
Looks like it's live right
No,
now.
it's not.
Okay.
What the heck? Right click while we're
Hey everybody, welcome to meeting number 93. Today we're going to be talking about a senior design project that AJ, and Evan worked on for their SOC. And we're also going to be going over some of the crackmes that we talked about, I think 3 weeks ago.
Cool.
Yeah. Go ahead.
Hello, hello, hello. Happy Wednesday, everybody. Yeah, another one of those magical days. Alright, as always, if you're new, just join the Slack. You know, Slack's where everything gets done. It is in any organization with us. Slack is kind of the heart. We relay information there. So, you know, of course, as always. Now for announcements. Again, organization planning meeting is every Sunday at Mr. Sushi, about 6:30. We encourage all of you to come, just to contribute in any way. It's really, we value everyone's input, and it's not, what can I say? It's not required, obviously, but you should definitely go to give your input, help guide the club in a different direction, or however you think it should be. We got a new lab head, Aaron Boyd. Woo! There he is.
Yeah, Aaron.
The king in the lab. Yeah, so I know Aaron's got a lot of cool stuff planned, but the Monday lab time is being changed, correct?
I think we'll keep it the same for the rest of the semester, but then might change.
Okay.
For now, it's still.
Well, for now it's Monday then. The king in the lab has spoken. Everyone obey his word. Next we got outdoor event coming up the 27th. Everybody know that volleyball court near Dabney?
Yes.
That sand place. Basically, we have an outdoor event there. I'll probably cook some out. It's BYOB. So everything that goes with that. Shirts and hoodies. We got those coming in. $25 and $35 respectively. If you ordered one, who do we talk to for those?
Basically talked to myself, Jai, and Ryan. We've been kind of the ones heading up the order. We're gonna be breaking even if everybody gets the shirts and hoodies that they wanted. So yeah,
Yep. So
barely breaking even.
everybody pick up your hoodie and your shirt. That's all there is to it. And then finally, Patel visit coming up this Sunday. If you signed up for that, pay attention for the Slack for carpooling, to drive, I know, hotel details, stuff like that. So, yeah, without further ado, we can get right into it, guys.
Yeah, so like what he was saying, we're having the Battelle visit this weekend, so raise your hand if you're going. All right, so if you guys remember, well, just a disclaimer, if you haven't signed up, sorry, it's too late. But for all of you that have signed up, raise your hand if you've actually signed up to be able to drive. That's about everybody who just raised their hand. So total, we're gonna have 18 people come, which is a pretty big group. It actually doubled in size after Aaron McKenty came, which is pretty insane. So I guess we got to figure out how to get all 18 of us there. Now, I know me, I will actually be there already on Friday, but I know most of you, pretty much all of you, will actually still be here on Saturday. So it starts at 11. Definitely want to be there early. So that means we need to at least, people need to at least leave like 9:30, maybe even 9:15 or 9 o'clock. And we can just maybe, or maybe even earlier than that, whatever, we can kind of figure it out. It's about an hour and a half.
Yeah.
It's an hour and a half to.
If you, on a Saturday morning, it'll be an hour and a half. Unless you drive like you're
Probably an hour 40.
So I'm gonna be driving and probably staying the night up there.
So that's another thing. We got who cannot stay the night in Columbus? Like who needs to come right back? that's here.
So y'all should better
So those,
figure out how to drive together.
we need to figure out how people who need to come back, like who's going to be doing those rounds, like who's actually going to be driving there and driving back and can take all those people back. So I guess to save time during the meeting, I can post a Google form and we can try and coordinate this stuff after the meeting. Please respond to that because, you know, it only happens if we get there. And this is probably the most important part that we need to figure out is how we're actually going to get there and how we're actually going to get everybody back safe. So please, I'm going to post a Google form at the end of the meeting. Please respond to that, and we're going to try and figure out exactly who's going to be able to drive, who's all going to be able to go there and back, and who needs to come back, who doesn't need to go back, and we'll sort that out all after the
We should
meeting.
have a question, be like, who are you?
Yeah.
Who are you bringing? And then, you know, we should
And
just
then
figure
we'll
it
actually
out.
give out numbers, then whoever needs a ride can call the people who are coordinating the rides, maybe group text or something like that. That'll all be
We have
coordinated, but we have plenty of drivers. It's just a matter of getting the right people in cars so we don't, you know, have too many cars coming.
Cool.
So 18 people, 4 people a car, so we should be able to figure it out.
All right, so I'm gonna take it over here with Evan, and we're gonna show you the Security Operations Center that we spent so much time on over the past year. So since we are required by our class to make a 10-minute video, this also is going to take place to that. And one of those requirements was to show a poster. I'm going to touch a little bit on the poster, but I want to show you guys the meat of what we have going on in the lab, not just sit here and monologue, but some little slide up here. So what we ended up making, can we turn off the lights? Like, backlights. Oh,
Hard to see.
thanks.
Good job, Chris.
Thank you, Chris. All right, better to see?
Yeah.
See back? All right. Yeah, so Security Operations Center. What is it? It's a nucleus to all of your security tools that you have in a business. Most businesses have their antivirus, their firewalls, your endpoint detection systems, your intrusion detection systems. There are all these different solutions for catching hackers on your network or seeing if malware is executed on machines. The whole problem with that is today you have all of these separate solutions. How do you bring them together and make something meaningful out of the data that you're getting? And that's kind of what a Security Operations Center aims to solve. The way we built it, it should be scalable up to the size of a company like Siemens or down to the size of like a small home. Essentially, the largest part of the SOC, or the most important part, how can I zoom in on you? Can't. All right, well, essentially, the whole description of what happens in the Security Operations Center can be described by this little logic chart here. The firewall is our entry and exit node for all traffic, so you can control who's coming in your network and who's leaving your network. That firewall is going to be providing the firewalling and, of course, you know, the internet traffic for your hosts, as what we call our assets or machines. And all of those in our lab are managed by Metal as a Service, and we're going to show you all of this, but this is essentially a tool that allows you to keep track of your entire machine, physical and virtual inventory, to see, you know, what they're running, if they're on, what not. And the endpoint detection system here tells you logs of what vulnerabilities are on the machine that are unpatched, what commands have been run on the machine, and other stuff like that for the endpoint detection system. That provides logs. So does that provides our endpoint detection system alerts and logs into our analysis. And our internal network, which also all the logs go through that because they're transferred over the network, is watched by the intrusion detection system Moloch and Suricata. This is the same setup that a lot of like huge companies are using to monitor their traffic. They're mirroring it all across on another wire and running it through Suricata to enrich all of their alerts. So basically, we take the endpoint and the in-network alerts, throw them into analysis, enrich them with open source intelligence, so we see what are other people saying is bad out in the field right now, and let's see if we have any of that here. So that's a pretty critical step. And then analysis provides the alerting to our ticketing engine called the Hive. So if you don't have a ticketing engine, you don't really have a way to efficiently work through these alerts. You just have all these tools, an onslaught of data, it's way too much data for somebody to just work through efficiently on their own unless they were doing specifically hunting. So the Hive is basically our instant response platform, providing instant response, and also allows us to organize all of the alerts that we see coming across the dashboard. So that's great and all. It's a lot of words. What does it do? How does it work? So have I been pwned? I'll just throw my email in here. I've changed my passwords since all these things happened. So all of these companies, Edmodo, Nexus Mods, hey, RuneScape PowerBot, RuneScape players, Ticketfly, Tumblr, all of these organizations, and then some Pastebin, they all lost their information, right? Most people that have had an email account in a lot of sites, especially like Edmodo, I know Under Armour got hacked. All of your information's out there. Your passwords are floating around. So all of this could have been avoided if these companies had a proper security operations center, or at least mitigated. So what do we got? Well, let's have Evan take over here and talk about this guy up here.
Yeah, so this is kind of just all of our UIs for our whole security operations center. Up here in the top left is a custom API that was written in Python and Flask. We got a couple components here. We can either blacklist IPs, whitelist IPs throughout our whole network. So if we know that a malicious IP is trying to do something bad, we can essentially just cut it off from our firewall and just say, no, you can't do anything. Right down here is our open source intelligence. It's a crowdsourced database of known IOCs, indicators of compromise, so a bunch of bad URLs, bad IPs.
Don't go to peptom.com. Don't go there.
And don't go there.
Bad site.
Up here in this giant map is our intrusion detection system, our IDS, which is basically monitoring all of the traffic going in and out of our network and our lab. You can also see from this map,
I'm messing up.
you can see where all of our packets, all of our traffic's going, which country, how much is going there.
20 packets to France. I don't trust them.
We had a couple packets going to Russia for a little bit, and we had to cut that off because it's not good.
They ain't happening anymore. No more NTP packets going to Russia. So yeah, like Evan said, this is our intrusion detection system. What this allows us to do is we can poke through any of the information being sent across the wire in our lab and even see the raw bytes and bits, what's getting sent. So we can kind of characterize and inspect packets and see what's going on. We can filter this by what country it's going to. We can filter it by what intrusion detection system rule alerted on it. And there's so much more. So this is being run right now in our lab. So if you've been on our lab computers, we've logged where you've been or whatnot, and this is kind of the overarching globe of where Cyber UC's lab is talking out to. I don't know why we got so many packets going to Australia. I ain't got anything wrong with Australians, but I don't know. Like why? It's like most of the United States, and then just like a shit ton in Australia. Whatever.
Is it the most?
Yeah, it's the most.
And also, like what AJ said before, because it's being mirrored, it doesn't bog down our network at all. Which is great.
So it doesn't stop any of you guys from hitting sites that you need to hit or anything, because we're not running it in intrusion prevention mode. If it was an IPS, it'd be in line with the traffic, and therefore, if we saw the rule hit, it would just automatically cut your traffic off so you wouldn't be able to leave, like a more active firewall of sorts. So down here, we have our intrusion detection system. As you can see, it shows us like the severity of alerts over time. I believe the alert severities go to like up to 16 or something like that. So 10 and 12, which are right here, are pretty high. I know you can barely see that. It's very tiny. This is mostly just looks good and lets you see a nice little overview of what's going on. But we have each of our hosts or machines in the lab, including virtual machines, are running Wazoo on them. It's just a script, sits in the background, watches everything, reports out to here. So we can see some of our top hits. Looks like Ubuntu 18.04 LTS has a medium severity CVE, and you guys can feel free to give that CVE at Google if you can even see it. It's like CV 2019 9740. I could click on it and we could go digging and see what it is. But regardless, we are scanning all of our servers in the lab for vulnerabilities so we can patch them before attackers even have the time to exploit those vulnerabilities. And it also gives us other events like when people log in and close. And it gets more interesting. There's stuff in here that detects very specific stuff like IP fragments with random offsets allow a remote denial of service through the fragment smack attack. I didn't know that was a thing. There you go. So you saw the network, the endpoints, the OSINT, the firewall IPs. And now over here is a really simplified small little view of MOS. These are all the servers we have in our lab and virtual machines we have in our lab. You can see which ones are on, which ones are off, what operating system they have deployed on them. If I clicked on one of these guys, it'd show me everything about that machine, just other information or whatnot, storage, memory, and you can even go through and configure network interfaces and whatnot. So MOS is not only a way to manage all of our machines, but also a way to configure them. So now we get to the cool stuff. This is what the whole SOC is about. So what we're going to do, we're going to run the attack.py here. All right, does somebody want to hit the Hack in a Box button? So what we made is a script that launches a number of attacks against our lab in real time here. So we have a SSH brute force. Then we follow it up with a shell shock attack, which tries to send a command, a bash command essentially, in the user agent string of a packet to try to pop a shell, to get access to some of these machines. And then along with a couple other things that we'll see here in a minute. So our detection script, in our correlation script, you remember that analysis circle on my logic diagram? That's running in the background every minute, and it's pulling the last 2 minutes worth of information, deduplicating it, and taking the events that we care about the most, the stuff that's interesting, and shooting it off to be ticketed here on this dashboard. So right now, and some are already showing up, but right now our IDS is going to work. We could look for these events in our IDS. Our endpoint detection system, it's going to work too. All of these components are working together in the background so that we have meaningful, actionable information on our ticketing dashboard. This is exactly how a security operations center functions, and learning this workflow is exactly how people out in the industry are catching and responding to hackers. So we talked about shell shock. Well, here's our IDS hit. It's a high severity priority, right? This is it's pretty bad if someone's trying to run, code on any of your devices through a shell shock attack. So I have it all coded out so that with this alert, it says some extra information: attempted administrator privilege gain, possible CVE 2014-1671 attack and headers. That is the CVE number for shell shock. I provide the payload that they sent, and I can scroll on this one. Hell yeah. So on this one, you can see that's the shell shock attack right there. I'm trying to pass in the user agent string /bin/bash. We can see our HTTP response, what our server sent back to it. That was actually our Elasticsearch cluster that it was trying to target, which is the database for all of this information. And then down here, we have all of our observables. Our source IP, our destination IP, the ports that it occurred on, even the source host, like the host name that occurred on, the content type that it was trying to do, whether it was GET or POST request. That's important when you're looking at traffic that could be malicious. If it's a POST request, that malware could be beaconing out. If it's a GET request, it could be pulling something down. And a signature ID for it. So what we can do here is go right to that alert in our intrusion detection system, because I had the link on there. We'll be able to pop open the alert and we'll see all of this extra information that we didn't need to see in that ticket. All this stuff here, Circata, tells us our Circata alert here. And then we can see the back and forth source destination traffic. So with that, we were able to pivot, figure out what the hacker's doing, catch the hacker, and then now we can take like the IP of said attacker, 10.14.0.201, and we could easily go up here, pop it in our blacklist IP, and blacklist that IP for incoming and outgoing traffic. So then, we've just now firewalled off a machine off our network that had malicious activity going on, and if we wanted to, we could probably even go and turn off the VM. if we know it's compromised and sending out bad stuff. So if you want to learn more about this, come hang out with the lab committee. If you're interested in working with this, I'd like to turn this into a competition thing where we have different tickets and alert pop up on here, and then people have to go through and analyze them and respond to them as people are attacking the lab. That could be a fun little exercise. But at the end of the day, that's the SOC in the lab. I won't take up any more time. So. Cool. So I think now you guys maybe
One more slide.
Oh, there you go. Just sig all in one. You got sig. Yeah, I got it. So who here has heard of Stuxnet? All right, so then you're already very familiar with that stuff. Basically, to kind of tie into how this is relevant to cybersecurity, if you're not aware, Stuxnet was an attack on hardware, an attack on PLC controllers from Siemens, actually. Hold on. And our project was actually developing our own controllers, so learning about how those things are actually built. And I'm trying to find how we can pull up the flash drive so we can show you. Aha. All right, so that's just kind of the background. Ryan?
All right, so our senior design was to go out and create a low-cost, low-profile industrial digital I/O motor controller. Now, the reasons for this are kind of few, but like very basically. What this does is it takes a control cabinet that's usually yay big, with a bunch of out-of-the-box components, like say from Allen Bradley or Rockwell and other things for power supplies, and then you have different hardware to do the same task that we're about to explain to you here. And those hardwares cost, just for the main controller, over $2,200. Each component after that costs $400 plus to combine into the system. And so what we try to do is minimize that to a smaller footprint into a package like you can see right there at the top left, and make it low cost. So what we did is we learned PCB design, and we decided that learning that was the primary of our senior design, and then trying to integrate all the functionality from that cabinet into this little box. Mike, you want to take
So the
off
whole
the
goal
functionality that is?
was just to basically make rapid prototyping extremely easy in any sort of lab setting. So it's extremely general purpose. I mean, you can really use it for any sort of testing of industrial systems. Just to kind of go over some features, some different things. Has 16 digital input and output ports that you can draw and pull from. Also has up to 6 power output ports, up to 7.5 amps per channel. Can also drive up to 5 different motors. One of those actually being a high current or higher voltage motor. And the voltage range for those motors are actually, I think it's rated technically up to 0 to 80 volts, but that's pretty insane for our specific model. So we're actually only spec'd it out for 0 to 40, 0 to 30 volts, just because that's a little bit more realistic. I mean, 80 volts for a motor, that's just an insane motor. But basically, what we did is we actually took that overall design and we scaled it down into 3 different models based on whatever application you might want to use it for. Maybe you don't need to drive 5 motors, maybe you only need to drive 1, so maybe this would actually be a better idea because it has a way smaller footprint than the others. So we actually went in heavily into PCB design, and in doing so, we learned a lot about shielding, and Ryan's actually going to show you guys
pass these around for you guys.
pass those out.
The biggest shielding portion of this project happens in this area of the board right here. So keep that in mind when you get it up close. This is board B. This is the control board where everything connects, where you actually like physically interact with the device and set certain things in different modes, and that's all abstract. You can program it in firmware and by serial commands. But I'll start with handing these around one here.
Yeah, Ryan. And I also put board B up, or board A up, if you want to
Yeah.
talk about it a little bit.
So we've been talking to Rockwell though, and Professor Franco, our lab advisor, our chapter advisor, has been talking to Rockwell, and
Board
we're gonna
A
try to get
schematics,
DLCs in
anyone
the lab, so we can start messing around with like
Board B
embedded systems design and embedded systems security stuff. So on a lower level like this.
And also to help kind of reinforce that whole process, I've actually been working with Rockwell myself to kind of maybe set up, maybe somebody comes in or something like that. Like I'm trying to go through the interview process, and in doing so, I've been bringing up cyber at UC frequently, and I've been trying to actually further build those ties between us and Rockwell, based in Cleveland. So maybe somebody will come down, go over exactly maybe this kind of a process, what they go over to actually do a mal or a test on one of their machines, because it's actually really cool. What they do at their facility is basically taking whatever their product is and trying to break it in any way they possibly can, which is exactly what happened in Stuxnet, which you guys are familiar with. I mean, basically, that was a lot more of a high level or nation state level of an attack, because there were multiple privileges surpassed throughout the attack that you could have only had access to if you had access through the company, which you only see if that's like very, very well funded nation state work. So to this application, maybe that's not too much of a concern, but those are the kind of levels of concern a company like Rockwell is facing.
And that's why we wanted to learn it, so that we could at least get the baseline of knowledge of how to create these systems. So then we can try and take that and figure out how to break it everywhere else in any other system that's been made.
And it also kind of brings forth the kind of hammering home what actually Aaron McCanty talked about last week, was how we always kind of just trust hardware. Well, that shouldn't be the case. And these are the kind of processes you have to go through to kind of understand why that shouldn't be the case, and why you should take these kind of considerations to make sure your circuitry is protected at the hardware level. You know, if you're interested in reading more about that, look up the spoiler attack, which is a combination of Spectre and Meltdown, which basically any computer that uses speculative execution is affected by. So this is just kind of an abstract way to look at that problem, but
we're not going to
feel
go
free to take a look at that stuff.
giant into the details.
Yeah, there's a lot. You could have an hour conversation about this, but just wanted to show you guys what we did, and maybe could draw some inspiration from it.
Right. Thank you
So
for your time.
feel free to take a look at those schematics and the drawings, and let us know what you guys think.
Cool. Where am I? There you go. Yep, no, Chris,
Yeah.
you using your laptop?
Yeah. Cool.
By my phone.
Oh, you have my phone. Except I'm on speech.
We're not going to be able to get the screen capture working, so because all we have is the. Hey, Chris. Chris.
What? They're switching to
No.
VGA?
Yeah. But like, you really just need to look into the cards, because we're not capturing off the screen anyway. It doesn't work. So we only have the projector up there. And
Yeah, my laptop is not like a projector station.
Oh, it can't do VGA. So this is this going to our stuff? Because if it's going to our stuff, it's not going to work. Is it going up? Sweet. What the heck? How's this working?
Magic.
Holy shit.
Okay, so we're just going to continue from 2 weeks ago. We did some of the modern binary exploitation problems from RPI6 course. So if you don't have Ghidra installed, we're just going to step through that real quick. So this is the NSA reverse engineering tool that we've been using for the last 2 months now. If you don't have it downloaded already, you can just go to their website. I'm not going to pause on this just because we've already spent so much time setting it up.
Did you see the email from Patel? I guess I forgot to mention that.
But
Everybody should have received an email from Patel if they're going. But it does say have Ghidra installed and have Python 2.7.
Oh yeah, bring your own laptops to
Yeah.
Patel. They didn't tell us to, but you're supposed to.
Yeah. Bring your own machine.
Yeah.
BYOD.
All right. So the problems are available on their course website, which is just if you Google RPI-sec MBE, it'll bring up their GitHub first. But then if you go here, about halfway down the page, there is the course website page, and that has under the third section, challenges.zip. That's where we're reading everything from. The ones on GitHub actually differ, so don't use those ones. All right, let's open these in Ghidra. I've already opened these in Ghidra, so I'm just going to pop them out. So this is 00A. We're not going to do 001 because they're identical. You guys see that? Everybody zoom in Ghidra?
I can see it.
Okay. The terminal too. Alright, so this is the first problem. If we run it, it's 00A. It asks us for a password. If you guys can see in here, it's looking for, it runs cscanf, which inputs data. There's a format string here. It's kind of obfuscated, but it's just %s, which means really input is a string. And then it compares that to .pass, which is a value stored somewhere else. Yeah. So here's where .pass is in memory. I double clicked from main to get to here. We get a series of bytes that we need to match up with, basically. So actually an easy way to do this is to, in Python, Python 1, we want to do that as a string and then do that decode with hex as the only parameter. So 3034 A. Okay, print that. So if we print that out, that decodes our hex string. You guys see that? It's off the screen. Just flip that in Ghidra. So our password for this level is good job. We can actually type that right into our challenge. It'll say password congratulations. So that's basically how most of these problems go. We can go ahead and open up the next one. We're going to skip straight to 1 because OB is basically the same thing. This one's a little different. We have a scanf and then we have an if statement that says if our input as a decimal is equal to hex 14.9a. So what we can do is pretty much the same thing. This Python hex print is actually very useful for a lot of these. Oh no. It's 9814. Uh-oh. What have I done wrong? No, it's an int. So for this one, we actually don't want to decode it as a string. We want to shift it into an integer. So in Python, you can do this with the int as a function. It takes a second parameter called base. That's a keyword parameter, so you have to name it. The base equals 16 for hex. We get our 14.9a here. Right. You can can see our number that we're comparing to in decimals. This is what we have to give the program for it to say we've won. One. All right. So those two are pretty easy. I think after 2 it gets a little weird. Here.
Ghidra, if you highlight over it, it'll actually decode it in decimal.
Let's go back.
Yeah, you hover over.
Should.
That's how we were doing
No
it.
way. Yeah.
Oh,
It gives you a lookup table.
Ghidra does it for you.
Yeah. That's really useful. 5274.
Woo!
Alright. There's probably a way to get Ghidra just to show you decimals by default. But I guess that's very useful too. Alright, let's go to our next one. I never analyzed it. Alright, so this one's almost identical, except we have just a different value basically, which we can hover over, so it becomes easy. 3387.24. Yeah, so there's nothing to that one. If you can do the one before that, you can do that one no problem as well.
This would be so much harder.
Yeah,
If for Ghidra.
Ridiculous.
yeah.
To look up
CTFs this year are
everything.
going to be hopefully way more interesting because Ghidra makes them all too easy. Yeah, so this is what we used to have to stare at, but now it's this. It's C code. It's less impressive. It's just 2. Alright. Alright, so this one's where it starts getting a little tricky. I don't know if you guys can see that from there. There's an obfuscated function right here called test. So we are still testing our input, but just not with a traditional if statement that we've been seeing so far. Clear over here. So if we actually dive into that function a little bit more, we can assume that we can actually see if I go back. We can see that we give it our input that we pull from scanf, so we can presume that's going to be our user input for every case. And we have another value here, but we can just at first assume that's the password, and we'll see that's correct later. But then there's just a simple if statement here, and then there's these kind of garbage strings that are passed right into a function called shift. So if we dive into shift, and we stare at it long enough, we can see that it's iterating over all the characters in the string, and it's incrementing -3 to their value as a C character, or an ASCII character, and then it's putting that into a new belt string. So it's actually doing a rotation -3 on these. It's a ROT3 decode, basically. So this is actually pretty much a Caesar cipher at the C level. And it's just kind of weird to look at, but if you stare at it long enough, you should see it. So go back to main. As for actually putting in the numbers, there's nothing any different here, because we can hover over it and it makes it twice as easy. 3387.24, the number didn't even change for this one. So we did it. We're only going up to 5, so this is going to end pretty quick. Alright, so we have a pretty much identical main here, except for our second comparison, our comparison function is no longer called test, it's called check. So if we go into that, we'll actually go back. There's also not a second parameter for our password to be on there. We're only passing in the user input. So somehow in check it's going to see if our password is correct. So we can actually stare at this long enough. I'm not going to go over the whole thing here, but I do have a slide that shows it very nicely. It's 4. So we go into check, and basically it goes through a while loop and it iterates over the whole string that you passed it, character per character, and it converts all those character values into numbers. And then if you can get it to sum to XF or 16 before you get to the end of your string, it'll say password OK. So this is 4. 16 is just 2 8s. Oh, incorrect. Is it ASCII 16?
15.
15. Oh, I misread it. It is 15. Sorry. Yeah. Yeah, so it has to sum up to 15, not 16. 10 minus 1 is 16.
Can I explain how the scanfs
Yeah.
stuff works?
So scanf. Where you go?
Two scanfs. There's a scanf and a miss scanf.
Yeah, scanf takes in data from the terminal typically. Where am I going? This is the one. And it puts it into a format string, so scan format, and then our format for this case is %s. Can you guys see that? There we go. So our format is just %s, which just means read this as a literal string of ASCII characters. But then when we go into check, there's another C function. This is actually defined in C of scanf, which takes the current character of our string. We have an index counting over this through the while loop. It turns it into a decimal, basically as another format, and then turns that it puts that resulting value into a location called current int. I actually renamed this as just one of the local variables for this function. You can rename stuff in Ghidra by pressing help. And then we iterate over the entire string slowly by 1. Oh, no, that's our counter. So we add that to our counter, and if our counter is equal to the hex f, which is 15, not 16, then we break, and then when we break, we go down into print password OK.
So it yanks digits out of whatever input you give it.
Yeah.
Sees they have 15.
Yeah. This is doing it by individual digit. You could do more than just a single character, but that's not how this one works. The Crackmes 5 is actually pretty complicated. Aaron, do you want to explain this one?
Yeah.
Okay.
So essentially when you run it, it goes into main and does the scanf like the previous ones and just copies the string. Then it goes to another similar function called check. And then once you get in there, it just checks to see if the string length is less than or equal to 0. If so, it'll cut out. Else, it'll grab each character of the string and convert it to a decimal, and then add it to the sum. And then if the sum of those characters is equal to 16, this time it's actually 16, it calls this parel function and just passes it the original input that you gave it. And once you get into that parel function, it converts that into a decimal value and runs a bitwise AND on it. And if that bitwise AND returns 0, then your password is good. Now, scroll over to the right. You'll have the bits up there. This one actually took us a while to figure out. It's actually only bitwise ANDing the last, or I guess least significant bit. And if you look at it, really all it's doing is checking whether it's even or odd. So whatever you give it, as long as the last character is even, then you're good to go. If it's odd, it'll fail.
Alright, so let's test that out. This is 5. Alright, so we have two even digits that add up to 16, which is what the first part of this checks. Or 2 digits that add up to 16, and then the least significant one is even. Alright. Is all that we covered on that one. The problems go up to 10, and they get significantly harder past this one, so we didn't want to cover them. Alright. That's it for tonight.
Where can we try these?
Where can you try these? On any computer.
Well,
They're on the modern binary.
Yeah, these are from the RPI Sec Modern Binary Exploitation course. So if you just Google RPI MBE, you should be able to find it.
Okay. We worked through them a couple weeks ago, so we'll do like the next set, like next week or something.
Yeah, after this they go a little bit into buffer overflows, so we're going to continue with that probably after the break, because next week's finals, and I don't think we want to do real content for finals because everyone's spraying them up.
Yep.
So in the summer, we will continue with shellcoding. After that, we're going to do overflows and actually controlling program execution, and then we're going to move into shellcoding. And then after that, we're probably going to move into return-oriented programming, which is kind of like the more advanced version of shellcoding. It's a bit messy. So that's where everything's at. Does anyone have any questions? Is that a question?
No.
Just a thumbs up? Okay. All right.
Cool. Thanks, Chris. Well, I will see all you guys this weekend. Should be awesome.
All right. Thanks for coming, everybody. Mike, did you say it right after this we're talking about the?
I'm just going to post a Google form, and I have everybody's numbers. So if, based off of what people said, I'm just going to assign, who's going to ride with who, I guess.
Or if you guys want to figure that out amongst yourselves, and then maybe we can have a
shoot
second
me
in
a
there.
text, shoot me a message on Slack if you want to figure it out yourself, like because it is an hour and a half
Or
ride.
just
You're gonna have to sit with this person, these
just
people.
put in the survey who you are and who you're taking.
Sure.
Yeah. So
Yeah. So I guess
We're
coordinate
all
that, and
people.
if there are people without rides, I'll just figure it out. But, if you have people